Thanks for that sweet intro. Hopefully the cuts are not so rough. Thanks to Trulia and to Librato for hosting. I don't know if you can tell because the branding is so sweet, but I'm rocking my requisite Librato shirt. Yeah, and this is monitoring, not just for numbers. So a little bit of background. I'm Pancakes, so if you hear throughout the night, people like ask me questions and address me as Pancakes. It's not weird. That's just what people call me. I can tell you the story of why that is later. And I'm working on better tools for ops people at a little company called Opsmatic. And this talk isn't really about that company. And I'm trying really hard to make it not about that company. But it is about the thought process that motivated us to start it. And that's sort of guided our direction throughout. And we've been focusing our attention so far on drift detection and how configuration changes are tracked and communicated under the broader premise that there's a lot of room for improvement in the tools for web and IT operators. And so a little story to set things up. As we were talking about all this, we attended a happy hour demo day at a local co-working space. And right in the middle of this, right as they were setting up to start the demos, the internet went down. And the hosts, they were theoretically prepared for this contingency. They had a backup DSL line, but and the Cisco Catalyst switch they had in their network was theoretically configured to even fail over to this line. But unfortunately, it was set up by a contractor who had been fired like 3 months ago. The new contractor had no idea how it worked. No one in the entire office knew how the switch was configured. So this is Jay Adelson telnetting to a Cisco Catalyst to figure out how stuff is configured because literally no one knows. So we knew that our general premise that there's a lot of room for improvement for IT and web operators was correct. So we got to work. Oh, and by the way, this is, as I was looking for that photo, I found this photo, and I just could not put it in here. This is Richard Crowley. He's right here in front. If you want to ask him about his photobombing skills later. Beautiful, beautiful job. So we went to work, and we started trying to figure out, throughout our experience in companies, some of which we worked together at, sort of along the way, what tasks and problems related to ops we found particularly demoralizing, and what situations left us longing for better tools, and feeling like we just were not using our time well, and like we could have been doing something better. And then we started thinking about, well, what should we be doing, right? And there's this whole, I like to think of the world as sort of engineering and ops being one thing with a common goal, and the common goal is to effectively get shit done or enable the business if you're a more mature thought leader type. So the problems are all shared, and the reason they're all shared is because the same things make us happy and the same things make us sad. And so happy state, customers are comfortably using the product. The product is evolving, hopefully quicker than competitors, and thus attracting new customers. And it kind of just becomes this virtuous cycle. And when you're operating under this environment, you're able to think strategically. You're able to communicate everything you're doing really well and document, and everyone's on the same page about everything. And things are kind of done in a methodical, kind of measured way. You hopefully do so well that you feel compelled to give a talk about how well-run your operations are, which I know I've done at previous companies. But other times, things aren't so good. The product is down a lot. Changes make it worse. Because they create more downtime, and you're not doing any of those things that were making you happy, like communicating really well and being on the same page. And as a result, you spend your whole time fighting fires and each other. And yeah, it's just not a great environment. And one of the things that contributes to this environment is surprises. And surprises are generally just bad things, right? Surprises are the enemy of strategy. If you're constantly dealing with surprises, you're constantly in that tactical mode, fighting fires, unable to actually pick your head up and really think about what's coming next, because what's coming next is another surprise. And so that makes the DevOps world unhappy. Now, we've come a long way. There's a lot of work that's been put into reducing surprises and helping sort of computers recover on their own and not be in a state that we expect. But unfortunately, as I said earlier, there's a lot more work to be done on this front. So here's some evidence. People are mad. Things are still not going super great. And this is Cliff. I blurred out the avatar just to be safe. I didn't want to click and see what Cliff's avatar actually was, so I just went ahead and did the safe thing there. So he's talking about idiomatic usage of Chef and Puppet. He's talking about actually trying to use the tools as they are intended and still getting drift. Now, so the million-dollar question in dealing with drift and sort of configuration management and changes is what's different. Right? We're going to keep coming back to this over and over again. And differences between hosts and environments and clusters are the most dumbfounding source of surprise because they violate some of your most fundamental assumptions. Right? When you assume everything's the same and it isn't, and you don't find out until everything's broken, and then you're looking for it frantically, bad times. So now policy certainly goes, using a policy-driven CM tool certainly goes a long way towards it. But policy implies that you know what's important. You know what to put in the policy, right? So anyone that's used Puppet and Chef, right? You declare the important parts of your configuration. The problem is that the domain for what is important is so enormous that there's literally no way of knowing. You're going to miss something, and you're not going to know it until, again, it's the worst possible time to find out. Related variant is what has changed, right? That's the same thing with a time component. Things were fine yesterday. They're terrible today. What happened? And so we get quotes like this out there on the internet. One of the scariest things I ever encounter is a server that's been running for ages, which has seen multiple upgrades of system and application software. This is Chad Fowler. I think he's at 6 Wunderkinder. An interesting thing that he mentions there is that drift happens both inside and outside policy. So like I said, right, like even idiomatic use of Chef and Puppet will cause drift. Non-idiomatic use, like for example, we'll get to a few examples, but are we there? Yeah, so the point is, no matter what you're doing, machines drift. It's a sort of natural byproduct of coming back to getting shit done, right? And we'll go through a few specific examples in a second. So the reason I'm here, right, and what we're trying to accomplish is start thinking in a way that basically says, well, that's fine. Drift is going to happen, and we're just going to deal with it, and we're going to accept it as a normal byproduct of work. And we're going to set up our tools such that we can just deal with it. But let's talk about what even is a drift, right? So drift is deviation from expectation, which occurs over time. And an important note about expectations is that some of them are implicit. So an explicit expectation is an assertion, for example, in your policy. You have a very specific thing that you want to be running. An implicit expectation, an assumption is, system libraries that I'm not declaring explicitly are all the same on this cluster. Pretty reasonable thing to expect. All of your web servers are probably running the same OS. libc is the same version. Who can confidently tell me that libc is the same version on all of their web servers? The guy that knows me from the time libc destroyed my production environment, and it took us a week to figure it out. He's asserting the right version of libc in production. So drift is subtle differences outside of policy scope, such as libc that's not declared anywhere. Drift is targeted partial CM runs, which is what I think Cliff was talking about based on the blog post by John Luce's that Twitter thread turned into. So you have your one of the things that people have started doing is instead of running the config management tools in a cron, like you're supposed to, they run it whenever you need to deploy something because running them in a cron is frankly expensive. So then one day you deploy something to your web cluster. In between, you, let's say, update a bunch of your user credentials for your employees. And then the next day, you deploy something to your database cluster. And now those clusters don't have the same user credentials. Hopefully no big deal, but maybe it's not user credentials. Maybe it's some super vulnerable library that you probably should have actually patched right away everywhere. So that's drift. Changes made during an outage. That's the most common thing that happens is 3 in the morning, your phone goes off, something's broken. You log on, you're like, Java, OOM, I don't know what's going on. I'm going to make the heap bigger and go back to sleep. On Monday, you come to work. You forgot you did this entirely because it was at 3 in the morning, and you literally have no recollection of it. No one knows you did this. 4 months later, one of your servers has a different heap size, and it's causing some other problem. And everyone's like, why is the heap size different? No one knows. Drift. Varying hardware configuration. This is a huge pain in the ass. So this is, it was shocking how many people that we talked to about this actually went, oh, yeah, this thing. You will order a machine from the same vendor that is the same model, that has the same hardware, theoretically. And the BIOS settings will be different. Some of them are important, some of them aren't. Some of them you'll notice right away, like maybe hyperthreading is off and you just don't have as many cores. And hopefully you notice that right away. Maybe you don't, I don't know. But some of them are less obvious and you don't find out until, shit show in production. A certain breed of EC2 users will recall checking what processor your underlying hardware was running on all of your VMs because certain processors would display this hilarious behavior where Java garbage collection would take 5 minutes. I don't know. It's just a thing that happens. So that's all drift, right? And all of these events are somehow, something was fine here, and then it's not fine here, and you don't know why or when it happened. So drift is difficult to find, and people use needle in a haystack as an analogy. I think shaving a yak for all sorts of reasons is actually a better analogy. Now, imagine a yak who has this massive surface area, right? This is a big animal. And somewhere in here is a pimple. And you got to find it. You got to shave the whole yak. And as you start shaving it, it dawns on you that the yak is bigger than you could ever anticipate. And as you keep shaving it, it keeps getting bigger and angrier looking. Right? As you're digging through like kernel configurations and sysctl and BIOS settings, you get angry too because who knows what else you got to check? I don't know. So, but for a computer, this is trivial. It turns out computers are excellent at dealing with structured data and are themselves piles of structured data. Right? All of those things that we talked about, package lists, BIOS settings, kernel settings, you name it, config files, although if you talk about something like Varnish, it's a little less structured than maybe we'd like. But the point is you can get a pretty clear idea of what's inside and what's different, and a computer will do it for you like that. So other things you need in order to get a grip on drift is a baseline, right? Like I said, we need an expectation, so you need to base your expectation on something. Fortunately, this is easy, relatively speaking. You have baselines all around you. So run lists or roles or whatever you call them, profiles, whatever your primitive for assigning particular classes to a node in your configuration management, that's a baseline. So for example, if you have 6 nodes that all have the same run list, and one of them gets a new version of a package and the others don't, that's drift. If 5 of them get a new version of the package and one of them doesn't, also drift. And those are things you can start to look for. Drift is also meaningless without context. This goes back to what we were talking about earlier. If you do a bunch of changes and people know that it's different, but they don't know when you did it, how you did it, who even did it, right? Who done it? You can't really get anything out of it. So computers are really good at telling you what's changed. They're not as good at telling you why, but they can give you a really good idea of who to ask. But hey, what am I talking about? This is a monitoring event, and the sort of punchline is that monitoring is the answer. I know it doesn't sound like it because I've been talking about CM tools a lot, but actually we've been using monitoring. That's basically, to me, is the main use case for monitoring, is identifying things that are different. Right? So this is from Brendan Gregg's post on using modes to figure out different traffic patterns. So in this case, this is the path that doesn't hit cache. This is the path that hits cache. So that's the difference. Right? But maybe in another example, this is the path that hits 3 nodes in your cluster that have libc version blah, and this is the path that hits a different version of libc. And that's probably important. Right? So we've been doing this already a little bit with monitoring. Etsy, ever on the forefront of tooling, released some tools for helping flag anomalous metrics. So what they're saying is instead of worrying about thresholds, just tell me anytime anytime a metric is behaving in a way that's unusual for it, because that's probably interesting. And that's sort of, in its own little way, also a way of looking for drift. And this is not a monitoring tool, but it foreshadows a little bit of where this is all going. This is Deployinator, which is an evolution of the, Flickr deploy tool. So particular environments, if your main sort of thing you deploy is a single code base, you can have this thing that just tells you when someone's deployed something. Now, this isn't truly monitoring because it's sort of you're pushing the data through the system as you deploy stuff. But it's the kind of thing that maybe will help with the problems that we've been describing, because at least you can always go back and see who's deployed what and when. And actually, these links will show you the specific diffs that were deployed, right? And there's other tools being built now that look a lot like this that are sort of starting to see the broader light of day commercially even. So then, as I'm preparing for this talk, Mark Burgess drops a gift in my lap. He's the guy whose work CF Engine he made, and then Puppet and Chef, and I think now SaltStack. I'm not sure how they all compare exactly, but I think they're all based on the same notion of convergent operators sort of enforcing a declared state, the policy that we've been talking about over time. And so in this book, very early into it, so I didn't even have to finish it. It's very long. He has this little bit where he says, control is predictability plus interaction. And then he says, but you can boil it down to certainty is the knowledge plus information, where knowledge is a relationship to the history of what we've already observed in the past, i.e., an expectation of behavior, and information. And information is evidence of the present, that things are proceeding as expected. So this is monitoring, right? This is we've recorded some state, and we kept it over time, and now we can go back and we can look at it. This is RRD tool for not numbers, which is what this talk is about. So I told you I'd come around. So it certainly allows us to be productive and strategic, right? Like this is what we're talking about. When we are not constantly surprised and we feel certain about our environment, this is when we're happy. So how can we get there? This is my dream here. This is my sort of little vision. So ongoing monitoring of infrastructure state, categorical data, so hence the name of the talk, right? So this isn't monitoring your CPU usage. This is monitoring structured data and how it changes over time. And then keeping a history of that so you can always go back and see. Ability to compare states, and find the pimple. And I'm talking both about two sort of real-time states of maybe two boxes or two clusters or, two boxes or two clusters, or across time. So the way things were yesterday versus the way things were today. Put computer activity into human context, right? So if you can see that a package changed, that's useless. If you can see that the package changed on Saturday night at 3 in the morning, and the only person that was SSH to any of your boxes is Johnny, probably Johnny did it, and you can probably ask him why he did it, and hopefully he'll remember. If you never ask him, it's gone, right? So, but if you can go back and find that context and what else was happening, right? Maybe also you know that 5 minutes before Johnny did all that stuff, there were like 1,000 pages, and that's probably helpful knowledge. Maybe the next time that page goes off, you say, hey, what happened the last time this page went off? And you can go back and see what Johnny did to fix it. And you stop sort of chasing your tail and trying to figure things out over and over, right? So you stop being so frustrated. You start being able to respond to surprises more quickly. You start getting out of it, seeing them coming, et cetera. Ability to detect and flag drift kind of falls out of all this, right? If you're constantly monitoring state and you're able to infer those baselines, like we talked about earlier, based on cluster names or roles or whatever, you can start inferring things like, oh, one of the nodes in the cluster changed and the others didn't. Probably should look into that. And notify the user, right? Like lodge that as this happened. This is a discrete event where, based on the way you normally upgrade your software, you missed one, right? Or you did one out of band or whatever. And then be able to act on it in a meaningful way, right? So the one of the things that I mentioned the blog post by John Vincent on this, or Lucis on the Twitter. He talks about the normal way that CM operates is, OK, CM runs, something should be this way. It's not. OK, well, I just changed it, and then I just keep going, and I don't tell anyone, I don't do anything. It's just fixed, right? But if you intended for it to be different, it's like, oh, well, we fixed the glitch, right? But you didn't actually fix it. So the ability to act on it meaningfully, right? And act on it even more meaningfully in being able to propagate those changes. Say, well, actually, that's OK. I want that on all of my boxes. This is actually fine. This is actually, as a result of that outage, we now know that that's a standard thing. You don't have to go try to figure out how to make it all work again. And you also know exactly what you changed, so you can kind of go back. So a lot of these things, if you're thinking about this real hard right now, start to sound a little bit like Git for code. And it's actually, we know that getting version control for our code helped a lot. So getting kind of a similar set of abilities for your infrastructure, some of which you can already get if you're managing your policy code under version control and paying attention to it and doing it thoroughly, but sort of get that sort of ability for your whole infrastructure and for things that are outside of your policy that you are sort of assuming underneath. And then utopia, and then we're all happy, and no one has to worry about it anymore. It's fucking great. Excuse me. And that's kind of where I think monitoring is going for things that aren't numbers. And if we can get there, then I think we'll all have an easier time with our jobs and be happier and do more productive, constructive things and see things coming. And that's all I've got.
You right at the end mentioned it looks a lot like Git. So why can't you just use Etsy Keeper and those sorts of things where it's basically checking Linux into Git? Where do those tools fall down in your mind?
Scale. Honestly, yeah. Some of the things I'm spending a lot of time on is just figuring out how to store all that data without it basically exploding. If you start doing that kind of naively on a node-by-node basis, I think you pretty quickly run into trouble. Furthermore, I think Etsy Keeper is primarily concerned with Etsy. I don't know, you probably configure it to do other files, but there's certain things that are not traditional file systems that you want to monitor that you can't get at through a traditional sort of file system kind of way. So you kind of have to normalize the data a little bit first to get at it. Does that satisfy your concerns? All right. That it? All right. Oh, swept away. We'll talk later.